As an example of the conic square, we'll do problem 16.1 in the book on page 285. It has relevance to some issues today. It says the police chief wants to know whether the city's non-whites feel that the police are doing a good job. In comparison to whites' evaluations, this information will tell the police whether they have a community relations problem in the non-white community. A survey reveals the data in the accompanying table. What can you tell the police chief? And base your statements on what you've learned from this chapter. We've reproduced the table up here. And they surveyed a total of 446 individuals, so that's your N. 296 whites, 150 non-whites. A total of 297 individuals say the police are doing a good job. 149 say police do a bad job. If you look at the substantive cells, we've got 76 of the non-whites saying police do bad job, 74 of non-whites say police do a good job, so it's roughly 50-50 split. For the white community, 223 say the police are doing a good job, 73 are doing a bad job. You can hypothesize that probably the whites are saying that police are doing a better job than the non-whites. You can run a chi-square test to determine this. So the equation's up to the top. We have to calculate all of our expected values for our 4 substantive cells in here in our 2x2 table. So we observe 76, 73, 74, and 223 in each of the substantive cells. We need to know if there's no relationship between race and attitudes toward police, what number should we see in these cells if race and attitudes. I'll put race at the top and then attitudes here. So if race and attitudes are independent of each other, what numbers should we see in those cells? So starting from the northwest and going clockwise, for the non-white police bad job, our expected value is going to be the row marginal for that cell, which is 149, times the column marginal for that cell of 150, divided by n of 446. That value $149 times 150 is 22,350 divided by 446 is 50.11. So the expected value, if race and attitudes are not related, we'd expect to see 50.11 non-whites saying that the police are doing a bad job. For whites saying the police do a bad job, moving over clockwise to the next cell, where we observe 73 whites saying the police are doing a bad job, we take its row marginal, 149, multiplied by the column marginal, 296, and divide by the n of 446. $149 times 296 is 44,104, and divide that by 446 to get about 98.89. So the expected value in this northeast cell should be 98.89. If there was no relationship between race and attitudes towards police, we should see 98, maybe 99 whites saying the police do a bad job. Going clockwise for whites saying the police do a good job. So that's 223 in that cell. The row marginal is 297. Multiply it by its column marginal of 296. Divide by the n of 446. 297 times 296 is 87,912. Divided by 446 equals 197.11. So that's the expected value in the southeast cell, 197.11. We should expect to see 197, 198 whites saying police do a good job. Non-white saying that police do a good job. The expected value is the row marginal of 297 multiplied by the column marginal of 150 over the n of 446. 297 times 150 is 44,500. Divide that by 446. Get 99.89. So based upon our survey of 446 individuals with 296 whites, 150 non-whites, the observed values in our cells, and also based upon the 149 people saying police do a bad job and 297 saying police are doing a good job, the numbers in red should be the numbers that we'd expect if race and attitude towards police are not related or if they're independent of each other. Your next step is to calculate the chi-square statistic. So for each substantive cell, you take the observed value, subtract out the expected value, square it, and divide by the expected value. Do that for each cell, and then add up all the numbers at the end. So again, starting in the northwest, going clockwise, for non-white police doing a bad job, we observed 76. We expected 50.11. Square that and divide by 50.11. $76 minus 50.11 is 25.89. We're going to end up squaring that and then dividing by 50.11. Get 13.38. Going clockwise, now to the white police do a bad job, we observed 73. We expected 98.89. I'm going to square that difference and divide by the expected of 98.89. 73 minus 98.89 is a negative 25.89. Square that and divide by 98.89. And you're going to get a value of 6.78. Going clockwise again, now to white police do a good job. We observed 223, expected 197.11. Divide by the expected 197.11. We're going to square this difference at the top. So 223 minus 197.11 is another 25.89. Square that over 197.11. And we get 3.40. Now the final, the southwest cell of non-white police do a good job. We observed 74. We expected 99.89. Square that difference and divide by the expected of 99.89. Negative 25.89. Square that and divide by 99.89. and you get a value of 6.71. The last step is to add up all of these numbers, so 13.38 plus 6.78 plus 3.4 plus 6.71. You probably already tell there's a statistically significant relationship, but we'll add them up. We get a chi-square value of 30.27. For the critical value, or the number with which we need to meet and or exceed for a statistically significant relationship between the independent variable of race and the dependent variable of attitude, you go to your table, look up the degrees of freedom, or that's rows minus 1 times columns minus 1. 2 substantive rows, please do a bad job, please do a good job. So that's 2 minus 1 times number of substantive columns minus 1, non-white and white. So that's 2 columns minus 1. 1 times 1 is 1. When you go to the 0.05 column in the chi-square table in the back of the book, for 1 degree of freedom, the critical value, I believe it is 3.84. Let's double check. Yes, 3.84. Compare that to the chi-square that you obtained. So we need to meet and or exceed 3.84 for a statistically significant relationship. We obviously exceed that with a chi-square of 30.27. So yes, there is a statistically significant relationship between race and attitudes towards police. Chi-square was I just erased it, but we know it was the chi-square obtained was greater than 3.84, somewhere in the 30s. So we can be at least 95% confident that race and attitudes toward police are related. So there's a statistically significant relationship between race and attitudes towards police. We're at least 95% confident. In fact, if you look at the table, to be 99% confident, we would need to meet and or exceed a value of 6.63. So we're at least 99% confident that yes, there is a statistically significant relationship between race and attitudes towards the police. We cannot claim a causal relationship. We know that there is a correlation. That correlation is statistically significant. To know which race might be driving the attitudes towards police, when you get a statistically significant relationship, is go into these cells and calculate the percentages. So let me erase the expected values. From here, in the non-white categories, out of 150 cases, 74 out of 150 indicated the police are doing a good job. 76 said they're doing a bad job. So 74 divided by 150, we have 49.33% of non-whites saying that the police do a good job. 76 divided by 150 is about 50.67% of non-whites saying the police do a bad job. So it's almost evenly split, 50-50. The non-whites are about evenly split in terms of their attitudes towards police. About half say they do a bad job, about half say they do a good job. If you go over to the whites, 73 say they do a bad job. This is out of 296 whites surveyed. 223 say the police do a good job. So 73 divided by 296 into a percentage is 24.67% of whites say the police are doing a bad job. 223 divided by 296 ends up being about 75.34% of whites say the police do a good job. Now, once we add these percentages in, if it wasn't already obvious to you, you can see what's driving the relationship and why we're getting a statistically significant chi-square value that very much exceeds the critical value of 3.84. You see that the non-white community is about split 50-50 in terms of whether they say the police are doing a good versus a bad job. In the white community, it's about 3/4 of the community saying they do a good job to only about 1/4 saying they do a bad job. So once you compare these percentages, you see the differences across the communities. And your analysis would be that we are at least 95% confident that whites indicate at a higher level that the police are doing a good job than non-whites, indications of their attitudes towards police. We don't know if this is causal. We'd have to look at a bunch of different other variables when we get to regression. So ultimately, what we can say at the end is that we're at least 95% confident that race and attitudes are related to each other. In your homework, when you run a chi-square in SPSS, on page 4 of the chi-square notes, I've given you the steps on how to do that and put some example variables in there. In this case, it would be how one's party identification affects the likelihood of participating in a charity or social welfare organization. So the dependent variable is likelihood of participating in a social welfare organization. I think it's coded yes or no. And then party affiliation is, I got multi-categories. So when you go to page 5 and look at the results, you see the dependent variable in the rows. It says participate in charity or social welfare organization, no or yes, and then it's disaggregated by the categories of the independent variable, Republican, Democrat, Independent, Other, and No Preference. The chi-square test, if we were to do it by hand, we'd get something similar to what the computer puts out. What you need to look for is the Pearson chi-square. You see that the value of the Pearson chi-square, it's the same thing we just calculated by hand. In this case, though, the chi-square for this particular set of variables is 24.569. And the asimp sig for that Pearson chi-square is 0.000, so it is significant. It is less than 0.05, so we are at least 95% confident. In this case, we're at least 99 or even 99.9% confident that party identification is related to whether or not somebody is likely to participate in a charity or social welfare organization. With this data, though, to try to figure out which categories might be driving that relationship, you would need to do, as we just did on the board, is calculate the percentages that say yes or no in that table. So you need to look at the percent of Republicans that say yes compared to Democrats that say yes, to independents, to others, to no preference. And then you might be able to kind of get an idea or hypothesis on which individuals of certain parties are more likely to participate in charities or not. But at this point, we stop and we say yes. The Pearson chi-square of 24.569 is statistically significant. We can conclude that party identification does affect whether or not one's willingness to participate in a charity or social welfare organization. If we want to determine if that party identification was a causal mechanism, this is what we'll do in about 3 weeks. We'd have to run a regression. So that's why we just stop here with the chi-square, because we're interested in causality. All we can say now is yes, there's a correlation. It's statistically significant. Later on, we'll get to regression to figure out what is definitely the driving force in that and the direction and strength.